Hello, good day. Welcome back and please join in to learn this another session in embedded system design on ARM Cortex M4. I'm pretty sure that you are revising so far and you are getting yourselves familiar with different registers where they are using and where they are used, and also how the different buses are connected to access to any memory locations, etc. If not, then please go back to all the revision videos to get yourselves more familiar with all the concepts, so this class or this session would be easy for you to go through. If not, if you join in one of the internship programs, and the videos will be there for you to learn. So today is day 14. Welcome in. Today we're going to learn about what is UART, and it's divided into two parts. Today's session will be UART transmit, and the next session will be the part 2, which is UART receive. In today's section, this is what you will learn. First, you will learn what is an UART and how that is used in STM32F411, how that is used in communication. And then you're going to learn between the UART versus the USART, what is the basic differences. Then when you want to talk about communication, it will be in the form of transmission or transferring data. To do that, you got to first transmit. So there are a few steps that you should learn and you should think, and there are a few registers that link to that USART transmit. So you're going to learn that from scratch. You're going to go into deep into all the registers, and you're going to copy all the addresses, etc. So you will learn all the steps. And then I'm going to take you to the demo session where you will learn to write all the code from scratch from line 1 to end, and you will be viewing that output in any hyperterminal. But I will also show you how to download Arduino IDE, because that is very good to learn as well, and that's coming in other course sections. So that's where we will verify the output for today. So let's get in. Before jumping into learning about today, I would like to give a small introduction about whom I'm representing. I'm representing A2DG. It's a startup by Anbukarasu brothers, my brother Alex and myself Arul in 2023. Both of us gathered over 20 years of experience, and we would really would like to help you all, to put you out there what we went through, 20 years experience and the knowledge. So it will be very useful for you to shape into a better version of you. So at the end of 30 days program, you will be a better version of where you are. So please stick by with us, and you will get to learn plenty of information from us. To convey, it's our mission is to convey our knowledge and our experience to at least 100,000 future professionals through online course. And the main advantage is you don't have to go to a face-to-face class environment. You can study at your own pace anywhere. All you have to have is a mobile phone or a computer and an internet connection. You can access to the videos and you can learn. So that is really one good big advantage. So please stick by us and you will get plenty to learn. A little bit about me. I am Arul Prakash Anbukarasu. You can call me as Arul or API, as persistent as I would like to share my knowledge with you and my experience with you all. I have over 20 years of experience working in few countries, in majoring in Australia, Italy, Singapore and India, and I've been working in most of these industries in renewable energy sector, where there is the power conversion from solar energy, from wind energy, and power systems from lead acid batteries, and network embedded systems that's linked with ATMs, the TCRs and POS, point of sale, banking automation systems, and smart parking operations. In a nutshell, my expertise lies on these three: on embedded systems, VLSI, and project management. So please stick by me, and I will make sure you will get to learn a lot, and you will be a better version of yourself. A little announcement to make. I categorize this into two different categories because of different benefits. All the video sessions that you've been going through, it will be all uploaded to A2DG YouTube channel. In order to be eligible to get a free e-certificate, you got to attend at least 28 video classes or video sessions. At the end of every video session, there will be an attendance link. You got to fill in your details and send it to us, and that will count on your attendance. So after that, we will compare and we'll give you the e-certificate. As part of YouTube regulations, we can't keep all the videos in there, so it has to be removed after 2 or 3 days. So in case if you miss a day and if you want to go back and revise, unfortunately you may be able to not to access to it. But that's where the second category is. I would strongly recommend you and advise you to join in one of our internship programs. And what would the internship professionals will lead you to? It will acquire you a priceless internship certificate. Yes, that is worth a lot. If you get into the interview queue, you will be sitting on top of the rest of the other engineers in the queue, because you are more confident and you already learned about microcontrollers and you know about registers. That's what basically is programming with registers. So you got that internal knowledge, and you got this 30 days platform behind you that where you learned everything, and this puts you on a right frame of mind, and you would be able to answer any technical questions or even any psychological questions, whatever, because your mind is fresh with full of ideas and full of information. And after you land on that first job, your senior engineers and your product managers, your project managers will consider you as a big asset, because you already did your hard work, hard yak, to put through those 30 days of learning. So therefore, in the industry, they don't have to give you a basic setup process, because you already know which IDs and where registers are and how you can program, etc. So therefore, they will just quickly jump on and assign you into projects. But I don't want to scare you, but these days it won't happen like that. Still, you will be able to learn from the senior engineers. They will take you through, but I'm just sharing my experience, what I went through. Not only that, you will get your own login, so you can log into our learning management system portal and you can go through each and every day session. And as soon as you complete one session, if you hit on complete button, then that will record your attendance for that day. And at the end of the course, the software will know that you learned 30 days worth of programming and course contents. Then the system will generate you and give you the certificate. So that's really priceless. And not only that, on top of that, you will get access to unlimited times to all our PDF materials, the course materials, all the source codes. You can go back and refer and you can practice with those source codes, and also unlimited access to course videos. For instance, you can pause it, and if you got some other emergency situation to handle too, you can go to that and attend and come back, and the videos will be there for you. You can revise and recap and forward and watch it all. And in the learning process, if you feel like if you got stuck anywhere, please contact our backend support team, and they are really good team, and they would be able to assist you to take you further in your education pathways in there. These are all the materials required, and please contact Pantech Solutions. They are a big manufacturing company and they would be able to help you to acquire all of this. Must is the STM32F411RE nuclear board. The more you start to practice yourself hands-on, the more benefits you will get. So please invest your money into buying these things. And I keep saying this to you, this won't stop at the end of this course. You can take this module, the hardware, and you can create your own design. You can create your own project. So it is money worth well spent. So please buy all this. So shall we get to communicate and see what the day unfolds for us? Let's get in and see what the communication is all about for us today. Today we're going to learn about UART. It is a communication protocol. Most of you would be knowing by now through your engineering degree course curriculum. UART has a abbreviation, and it stands for this. In case if you have forgotten, I'm just giving you a recap. If I'm repeating myself, sorry. Just to give you a little bit of introduction, I'm starting with this. UART stands for Universal Asynchronous Receiver and Transmitter. It is a widely used communication protocol if you take in terms of communicating between microcontroller to the other microcontroller, or from a target microcontroller to a host PC, which is the computer, and also you are targeting the FPGA board to another communication board. So likewise, UART can be also used in all those useful communication, and this UART also has been called by other names. For example, you will hear us in the industry, they'll call us serial port or COM port or RS232 port or RS485 port. The basic difference with the RS232 and RS485, we are talking today in terms of communication. When you think of communication, it's either data is involved or other form of communication like video or verbal, that sort of communication. But we are learning about coding, and therefore a large data of communication involves here. When you talk about data, then you have to transmit the data and you have to receive the data. So that's the main purpose of the UART. And RS232, to transfer that data, what you want to transmit, it can cover up to areas from 3 meters to 10 meters. So that's roughly the basic range. But if you want to send your data for long range distances, then you have to think about going to RS485. That's covered for large distances. So as I said, it's very common and very simple to use. Why it is very simple? It has only 3 wires in communication. Those 3 wires are transmit, receive, and ground. So all these 3 pins are used to communicate for data transfer. So this is all about UART. Now we're going to know about the differences, the basic differences between the UART and the USART. As most of you would have learned all this through your engineering degree, but I'm just giving you a recap. UART you already learned just a bit. And what is USART? USART stands for Universal Synchronous Asynchronous Receiver Transmitter. And what is that involved? As you know, in UART and USART, you have to transfer data or send data from one section to other section or from one machine to other machine. Therefore, a data communication happens. And there are 2 modes of communication protocol, a serial mode protocol. One is UART and USART. In USART, all your data will be synced with a clock signal. So for using USART, you need to have a clock signal, and every data will be synced with that clock pulse, and every data will be linked to that and transferred. Whereas in UART, you don't need a clock to sync. You can just use a frame bits with a start bit and a stop bit, and you can transfer the data. But that's where it requires extra bits to transfer data. So that's where USART is really handy, because you don't need that extra bits. When coming to memory allocation, memory storage, those extra bits all count. So USART is really good. And this is the timing diagram that we are going to learn about it today. When you want to send data serially, there is 2 different sort of communication. There is a synchronous communication and there is the asynchronous communication. In the synchronous communication, you can transfer bulk data in a frame structure because it's going to sync with your clock signal, and you can keep sending data because it's going to sync with the clock and it will just push through the data. Whereas in asynchronous communication, you can only transfer to a byte-sized data in the frame structure. So you need extra bits to transfer. You need to have a start bit and 1 or 2 stop bits with a parity bit for checking your error functions. So this is basically the 2 different way of communication. You can do via asynchronous or by synchronous. So this is the basic difference when you talk about 2 communication standards of USART and UART. And this is what it explained here. Asynchronous transfer does not require clock signal. However, it transfers extra bits, that is the start bit and the stop bits. So that adds more to the memory allocation during data communication. Whereas In synchronous mode, you don't need these extra bits, start bit and stop bit. Instead, your data will be synced with the clock signals, therefore the clock signal is required. So this is the basic timing diagram, and eventually you will learn in the projects that how this is all transferred. This is a simple block diagram to illustrate about how the actual communication happens. This example shows two UART communication ports in two different areas. Again, you have to first make sure your microcontroller and your PC are compatible to use UART or USART mode. Most of the PCs have serial communication, so you don't have to worry much, but still it will have the 3-wire communication, the transmit, receive and ground. So most PCs will have that, whereas in some microcontrollers you may not have the support of USART. It may have an UART. For example, 8051 has only UARTs, it doesn't have USART. So likewise, you have to check with your microcontroller and be familiar with what communication mode that microcontroller is used. So in order to target or in order to transfer the data communication, for example, in this example, it's shown from communicating from my FPGA board to a host PC, that's a computer. So for example, if you want to transfer the data from UART transmit pin, it has to be connected to the UART of the host PC on the receive bit pin. So you can't transmit to transmit. So once you hit transmit, it has to receive on the other end. And once that's received, then it has to transmit from here to get to the host or to the previous location. So likewise, the host PC from the transmit bit, it will send that data, and the UART receive pin on the Xilinx FPGA will get the data. So this is how the transmission happens. And when we talk about communication transmission, the one main thing is you have to maintain those pins on the same speed. In other words, you have to maintain those two USART pins on the same baud rate. What is baud rate? As you all might be knowing, baud rate is nothing but transferring bits per second, transferring data bits per second. So that's what baud rate is. And as you all know already, there are plenty of baud rates out there, but the standard one everyone mostly uses the 9600 standard baud rate. So if you set this baud rate with 9600, then this has to be set as 9600. Otherwise, there is no data communication, there is no transfer or receive happens, because for a start you will get plenty of errors and you won't even start to communicate to send any form of data. So please make sure both sits on the same baud rate, nothing changes, maintain the same speed. So that's what really counts. Now let's move on to learning about different parameters that's associated with UART and USART. As most of you would know, there are different baud rates. Most commonly heard baud rate that we know is 9600. There is 19,200. There is 115,200, and there is others. Generally, the data bits come in 7 and 8 bits, but most widely used is 8 bits, but there is also 7 bits. And there is also parity bits used with on and off. This is where you can get to use your odd and even parity to check for your error parameters, error checking. And also for data transfer, you can also use stop bits. In general, it will come as 0 bits, you don't need anything for USART. But in terms of asynchronous, if you want to transfer the data, then there could be, you need occasionally 1 bit or 2 bits to tell the microcontroller that data has been received or transmitted, and then it stops. And also there is 3 different flow controls, none on chip and hardware, and this course is all about hardware. You are targeting the hardware board, and make sure when you start to program, you always connect to your hardware, otherwise it will throw the error. So these are all the when we talk about data communication, you are trying to send data from one communication to other, from one machine to the microcontroller, or from other microcontroller to a host PC, or from FPGA board to microcontroller UART board. So for that you got to memorize, you don't have to memorize, but you got to be aware of using all these 8 steps to transmit data successfully. So this is what you're going to learn, how the transmit bits are used in terms of this STM32F411 bit microcontroller. We're using Nucleo F411RE board. And these are all the steps. First, you got to enable clock access to GPIO. If you cast your mind back to that LED blinking project, you would understand you have to enable that clock first, so that the microcontroller knows that which port that input or output is coming from. So that is why the USART needs clock access to tell or alert the microcontroller. So that's a must. And every port and every peripheral is associated with internal registers, and that's how you can write a program. You have to write program to set those registers or enable or configure those registers. So the first step is to enable the GPIO port, where the USART will be configured with any one of the ports. We are taking as GPIO A, it can be GPIO B, C, D, whatever, but as a standard of practice, we'll start with GPIO A. So this is where if you want to enable the clock, then you got to learn which bus is connected to which port and which peripherals are connected to which bus and how that's communicated to the microcontroller. So I'll show you that in the functional block diagram, where how the ports is connected via the bus and how that's connected to the microcontroller, that you will learn shortly. And the second step is to enable clock access to your USART for data transmission. So again, you need to go to that register, and you need to see where that's communicating to which bus, and you have to enable that bus. And then now you got to set your the third step is to set the port, whichever port you are using, you have to set that to an alternate function mode. As you learned from previous sessions, every port can be used as an alternate function, meaning it can be used as an input, the pins that associated with all the ports. It can be used for input, it can be used for output, it can be used for alternate function mode, or it can be also used for analog mode. So there are basically 4 port modes that you can use, and set and configure those. So when you say PA2, what is that stand for? I'm sure most of you would know by now. It is nothing but port A and pin 2. So you got to set port A and pin 2 to alternate function mode. I'll tell you why we are learning only PA2 today in the next slides. The fourth step is you have to set what type of that alternate function is going to use for that particular pin. So you got to use, today we learning about USART transmit, so that has the alternate function of 07. So you need to set this port as alternate type and link with the memory mapping, alternate function mapping as AF07. Then the fifth step is you have to configure the USART module, and then the sixth step is you have to configure the baud rate in order to maintain the constant, the same speed, not constant speed, the same speed as it transmit to receive. And then you need to, the seventh step is to configure the transfer direction. You got to tell whether you are using it for transmit or you are using it for receive. So that's a must there. And then make sure finally you enable that USART module, and that will start to communicate with the data transfer. So these are all the 8 points that you have to, or 8 steps that you got to really familiar with before jumping on to writing a program. So now let's go into IDE, and I will show you step by step. You're going to write every line of program, and I'll going to explain to you all the basic things that you need in the IDE, and you'll learn for yourself. Just before going there, I would like to show where I'm taking all this reference from. So if you know, you got to download all those reference manuals, and if you want to see how this USART is communicated, you need this block diagram. And this is the block diagram that's in the reference manual on on the data sheet on page 14 or 15. If you go there, you will see this. This is the outzoomed view. So once you zoom in, this is where the UART lives. So it has 3 USARTs. USART 1, USART 2 and USART 6. For our learning today, we're going to use USART 2. And that USART 2 is connected via APB1. APB is nothing but it's a peripheral bus, advanced peripheral bus, APB1. So I'll show you where in the data sheet. So I'm inside reference manual. So I'll go to data sheet. I downloaded all of this. So if you go to page 14, this is sorry, I think maybe 15. Oh, sorry. 14. I can't type, sorry. Okay, it's on page 15 on the datasheet STM32F411RE. I'll zoom in for your reference. So if you see this functional block diagram, this is the ARM Cortex M4 microcontroller. And that's connected via the AHP bus matrix, and that's bus matrix is connected to AHP1 advanced high performance bus, and that bus is connected to various ports. So in order to communicate from any ports, or in order to communicate anything that's listed with all the pins, you need to enable this bus, and to enable that you need to enable the clock first. Then today we are learning about USART and data transmission, data communication, and we are using USART 2. And if you scroll down in the same functional block diagram, that's where the USART 2 is, and that's connected and interfaced via advanced peripheral bus 1, and you got to enable and give clock to this USART 2 because we are learning about USART, and therefore it needs a clock to synchronize your data when you start to transmit. So that's the purpose, to enable this clock. And if you go there, then you will learn that this is communicated via this bridge, and this bridge is connected to the AHP1. That's how it communicates to the microcontroller and so forth. So you get the transmit and the receive by this way. And as you know, every GPIO pin will have associated GPIO purposes. And this is where the alternate function is. And I'll show you this. Every pin, as we are learning today, we are learning about port A2. Why? We are learning about USART 2 and we are transmitting the data. So every GPIO pin can be used for alternate functions. So that means the same pin can be used for various purposes. For example, the same port A2 pin 2 can be used for timer 2 or timer 5, timer 9, I2S or event out. So it's a multi-purpose, if you like. It's the same pin, depends on how you set. It can be used as for different purposes. So that's what the alternate functions are. And again, if you go to the data sheet, you will see this table. I'm sure it is page 47, I think, or 46. Sorry. Okay, we need USART 2 TX. Okay, this is what we need. So it is on page 40. If you go there, this is the alternate function PA2, port A2, and you're going to set that as a USART pin, as a transmit pin. It is on table 8 on page 40. If you go there, this is the pin definition, about to say which GPIO pin can be programmed for which. So these are all different packages. It comes in different package. Again, in this package PA2, whatever you are using, you need to set that pin as that. So likewise. So if you zoom in, the registers that's going to connect is the CTS, which are not learning today about. We are learning about USART transmit. So you got to use PA2. So that's why today we're going to concentrate on PA2, the port A, pin 2 as transmit bit. And then we were just learning about alternate function, how one same pin can be used for different functionality, and how it can be mapped when you want to communicate with the alternate function to the microcontroller. We're learning about port A2 because we're going to use this as an UART2 transmit pin. And if you link in this table PA2 and USART2 transmit, it's using AF07, alternate function 07. There are alternate functions from 00 to 15. So if your bits, or if your pin lies between 0 to 7, then you need to go for alternate function low registers. If your pin belongs to 8 till 15th bit, then you have to go to the alternate function high registers. So that's the two different regions that you should consider about. And this is about the previous slide. So we're going to set this as the alternate function as the transmit pin. That means this is bit 0, on the port register. This is in control status register, whereas I'll show where this is control status. It will be on the reference manual. I think on page. Okay. While I'm here, I'll show the clock as well. Just going a bit fast to get to the address that I wanted to show. Just one sec. Okay, this is the peripheral that you want to enable first. HB2 AP1. Okay, this is the USART that we're going to use. RCC. It is under RCC and APB1 USART2. Bit 17, you need to enable that pin. APB2 RCC PDCR, you don't need that. Trying to get to the control register to show you how the alternate function is mapped. System config. This is all system config. Alternate function GPIO. Okay, you will see that in the GPIO. Sorry, I forgot the page number, so I'm doing the hard way. So this is where the your information that if you already gone through, then you would know exactly which page to go. Otherwise, you can do search there, but then yeah, there are a few other ways that you can go about to learn where exactly everything is. So I'm just taking you via the. Okay, this is the port mode that you have to register. You need to set these register. This is the port A, pin 2. This is pin 0, pin 1, pin 2. And you're going to set this as alternate function. So you need to write 10 in this mode. So mode 2, you got to write bit 5 as 1 and bit 4 as 0. That you will learn in the program. I'm just showing while I'm here looking at the registers. Speed registers, it's a pull up, pull down register. We don't need the data register for here. Want to show you, okay, this is the register I wanted to show you. It's a GPIO alternate function low register, meaning the alternate function selection for port. If the output is between 0 and 7, so it's 0 and 7, it's a 32-bit. So you need to go with, that's port A, pin 1. As you know, STM32F411 has 16 bits of this port, GPIO port, so you can use that. So port pin 1, pin 2 and pin 3. So you need to use these 4 bits. So you got to use from the functional mapping, you learned AF7. So you got to set 0, 1, 1, 1. So that means bit 11 will be 0, bit 10 will be 1, bit 9 will be 1, bit 8 will be 1. So this will represent your function map with the port as 0111. That's the GPIO registers. Okay, so there you go. So the next one is there is a different baud rate calculation. So when you write your want to know which baud rate you wanted to put that in the calculation and use it in the program, as you know, the going by the previous session, this STM microcontroller peripheral clock is 16 megahertz, so that is the 16 megahertz, and we are considering to use the baud rate as 9600. To calculate the baud rate, this is the formula. So it is peripheral clock plus baud rate time divided by 2, the whole divided by the baud rate, and that will give you a baud rate register calculation. So we are learning about BRR, and this is the formula. So if you do the math and if you calculate and everything, you will get the value. You end up getting 1667, and if you convert this binary 1667 decimal value to hex, this is what you get, 0 cross 0683, and this is what you have to load into the register, which you will learn shortly in the program. Okay, let's go into IDE, and I'll show you how to write program from scratch. So let me minimize this. Let me minimize this now. Minimize this. I already opened IDE. As you can see, it's already opened. So if you haven't opened, then at this time, this is a very good time to check whether your board is connected with the computer. So as you can see, the LED is on. I communicated this board to my computer via the USB cable. So my hardware is ready, and my programming will start now. So I'll take that view off so you can see the screen. So once you open, this is on the previous example, so you have to go to File, starting as new project, File, New, STM32 project. I think we are going on a bit, so why don't you go and have a short break, and when you come back, I'll take you step by step, line by line, and I'll teach you how. So go and enjoy that short break. I will catch you shortly in about a couple of minutes, and go and have some nibble to have a bite on. So I'll catch you shortly here. Hello and welcome back. I'm sure you enjoyed that stretch or whatever you wanted to do and have a something to have a bite and got the energy flowing back. Okay, we left it here and I'll start from here. So I opened the IDE and I went to File, New STM32 project, and this is the window it will open. Here you have to select board selector, and you got to, if you know the part already that I know because I'm using the board Nucleo F411RE, so you just type in there in the search in the commercial part number, and there it is. Just select that and then click on next, and we need to give a project name. So today we are on day 14 and we are learning UART transmit, so I will resemble that, day 14 underscore USART transmit. So we're learning about transmit, and since we are learning from scratch, you have to select, I have to select to teach you today as an empty project, targeted project type. And if you also want to start any coding from scratch, this is what you got to set as an empty, and then hit finish. This will start to generate the project tree and it will get all the necessary files linked to it here. So as you can see, day 14 is there. I will just minimize all of the other ones that we don't need of. So day 14 there. I'll close all the previous files so you won't get confused. Okay, so we have to go to the source. We have to go to the main program, and as you know, anything that's on the green is comment, basically, with slash star and finish with star asterisk and slash, and that's in comment. So it's to say what file name it is and who has written that and which part of this program in terms of the whole programming body. And you can leave the, excuse me, and you can leave the microelectronics and a bit of license version in there if you want. Since we're learning from scratch, I will delete all the internal programs not to confuse you, so I'll leave just that. Okay, first we learned about how we need all the bus information and the peripheral information. When we talk about bus and peripheral information, everything controls and controlled by registers, and those registers being programmed to the address of that particular register. So in embedded C programming, those addresses are the must. So you need to go into details of every special function registers and look for that address, copy and bring it here because you're going to use it, and I'm going to show you how. So just before doing that, I'm going to compile this program so that the .elf file will be generated. So I'm going right click, build the project. And this is to do the initial setup. So when you want to debug, it will start to debug to your target board. So that's what the basic steps are. First, you have to generate the .elf file that you learned previously. It stands for, executable link format file. Good. It's building 98%, so 0 errors, 0 warnings. So that means it has what already generated elf file. So I'm going to do the debug option settings. Click debug as and go to debug configurations. This is to set up your target hardware, and you have to select which project you are working on, so that particular .elf file will be linked to that project, otherwise you'll get plenty of errors. So make sure you double click on this STM32C application. When you do the double click, and if you have already created the program tree, the project tree, that will go directly to that into the debug mode. So this name comes through. Make sure the debug, this reference path is set to .elf. If not, then you will get another error as well. So make sure you know how to get there by click on search project and browse, all of that. So the basic two things that you have to do is inside the debugger tab, you have to click which interface you are going to do. in this case we are targeting on Nucleo F411 ST-Link. It's a ST microelectronics board, so you need to enable that programmer. So the STM32 has a built-in programmer. That's what used for debugger. So you need to enable that in order to debug. That's basically it. So you need to enable that. On the serial wire viewer where you want to see the output, so click on enable and then hit apply and then click debug. This will generally start to change your perspective from it will say asking for permission, from C++ perspective to debug perspective. So that's the these two steps we got to do. So it came as not detected, so I'll do debug because I just set the configuration. This time I'll go to STM32 application. This will start to pile up and will change from the C++ mode to debug mode. It's on 79% if you would see here. And once it changes, then we can go into the special function registers and we can look for the registers that we need and those addresses. Okay, today we are dealing with STM32F411. So we got to go here and copy all the addresses that we need to use it in our program. As you know, the first step is you need to enable the reset counter clock to tell which port you're going to use. So you need to enable the clock for that. Where that will live? That will live under RCC register. So you need to elaborate that. And you have to enable AHB1ENR. First, let's go through all the special function registers and copy the addresses and put it here for easy access, and then I'll take you through to the program. So you need to copy that address. So the first one is you got to enable port A, that is the GPIO A. For that you need this register RCC AHB1 ENR, and its address is, you need to use this address letter, so you got to copy this and keep it here for our reference. So okay, what is the next step we need? I'll copy this because all we need is just the register. So I'll copy so now we have to enable the peripheral bus, the advanced peripheral bus, meaning you need to enable the clock. Sorry, enable peripheral bus. Enable peripheral bus, spelling peripheral bus. Okay, and where will that be? Again, it will be in the reset counter clock RCC, and you have to look for APB1 ENR. So APB1 ENR, so that's the one you want, peripheral enable. So you want this address APB1 ENR. You need the whole address, so copy this and paste it here so you can use it for the further reference. So the next one is APB1 ENR. Okay, so now we need to set the port A mode, the port A2, into alternate function. So to do that, you have to set couple of registers. So I'll just copy that. Now set, this is just for reference, so you don't have to type all of this. I'm just copying all the addresses, so it will be useful for us to program later. So set port A for alternate function. And where will this live? Where will these registers be? You have to go to GPIO registers. So we are using GPIO-A register, GPIO-A. So we are going to use as the port modder. The port modder is the one where you're saying what type of mode you're going to use. So this is where you need to set that as a transmit mode. So it's inside GPIO-A, GPIO-A, and first you need to use is your modder register. You can call it as, for naming convention, be much easier, GPIO-A modder, and then copy that address 040002, that address, copy that and replace with this. Now we need to say the alternate function, whether is it your low register or high register. So you got to say that. So now the next step is to set that AFR, set port AFR alternate function type, what type it is. So where will that be? It will be on AFR low, alternate function register low. So you need this because we doing data transmit today, USART, and that's connected to port A pin 2. And if you see the table 9 alternate function mapping, and if you see that it's using alternate function 07, and any pin that you want to interface between 0 to 7, then you need to use AFR low. Or if you want to use pins from 8 to 15, you got to use pins from 8 to 15 as high, AFR high. In our case, we're going to go for AFR L. So we need to type that. It will be under GPIO GPIO A AFRL, and then copy this address 0x400. Yeah, copy that and replace to this. Okay, so now we let the alternate function type and alternate function to use that same pin. Now we need to go and configure the USART. So for that you need to go and set now configure USART module. And where will the USART module will be? You need to look for USART 2, which will be under peripherals, not peripherals. So it will be inside STM32F411. So there is separate peripherals session to it. So we are going to use USART 2. So it will be in USART 2. And we're going to use, we need status register, we need data register, and the baud rate, and the control register one. I'll explain to you when we write programs. So we need all these four, basically all the four USARTs. So I'll start with USART2 USART2 underscore status register first. Status register. And what's the address of status register? Double click. The status register address is this one. So come here and replace that 4400. Oops, sorry, not there. What am I doing? Sorry. type GPO. Okay, here it will be on USART 2, which is will be on USART 2. You need the status register, and the address is this one, 4400. So likewise, you need the data register, and also you need baud register, you need the control register. So you need control C, data register, baud register, and CR1. So we are still configuring the USART mode. So we need, next one is data register, which is this one, because this is where you're going to save the data to communicate, and you're going to transfer it. So everything has to, all your data will be sitting inside this register, and you're going to use this register to communicate. So that's why you need a data register. Okay, 4404. The next one is baud rate register generator. So that's the address for baud rate. Control C, come here and change that, Control V, and this will be baud rate register. And then the last one is control register 1. We're going to use control register 1. So you need that control register, and that's the address you need. Control C. Okay, so it is a very good practice. So once you know which register and which bus and which peripherals it's all linking and going to interface with your microcontroller, then the good easy way is coming here, going to window, show view, and if you click on SFRs, and this is what you get, and you go and get all the registers that you're going to program with, and you're going to write program to locate to the address. So that's really key. So now we did the easy bit. So now we'll start to declare all this in a pointer variable so that it can be used in the main program. So the next step is you're going to declare all of that into a pointer mode. So to start off that, pointer mode, yeah. Let's switch. As you see, address. Okay, we did copy the address. Okay, now we need to configure the pointer. So to do that, this is where this will be really handy. We are inside the include. So you got to do this, and the pointers will be specified with a small p. So that means it's a pointer, and you got to define all the pointers with all the label names, and then you got to typecast this, and link that with the addresses. Control C. So this is the first one we are declaring. So I just copy that. You got to do that 8 times. So you need 8 of these. Control C. For good practice, if you don't confused, you can type in line by line, which would make your life a lot easier, because if something goes wrong, then you know which line you typed and where you want to go and change, so which is always really handy. So the second one is we're going to set this pointer APB1ENR. So copy that, come here and paste it, and then the address for that is this one. See how much easier it is, because you already went and checked all the registers that you need, and you copy that address, and you just come here and write one line, and you can this is how you can do if you want to do fast coding. So this really helps, but this will come with practice. Don't get panic if you're not up to speed. Just go as fast as you can and try to learn slowly. So slow and steady always wins the race. Okay, so the next one is the modder. We're going to use the port mode register. So for that, you need to copy the port A modder, copy this and replace it here, GPIO modder, and the address will be this one, for Control C, and the address will be this, Control V. Okay, that's done. So next one is you need to set that alternate function, whether it's a low or a high register, Control V, and then you got to copy the same that belongs to the same address there, Control C, you come here and Control V it. And then next one, you're going to set the status register and data register and all the, you're starting to configure the USART now. So you got to set first USART status register. USART status register, and its address is this one. So copy this address and come here and leave it here in this address. And then the next one is USART data register. Copy this data register name, Control C, and you got Control V, and its register is this value address, Control C, come here and replace with this 4404. And the next one is USART baud rate register. Baud rate register, and its address is going to be 4408, ending with 4408. Okay. Oops, sorry, I did wrong. Sorry, you must be telling me, hey, stop doing that, you're doing it to the wrong address copy. See, this is what happens if you want to copy. Okay, now we need to declare the control1 pointer control status. So for that you need another declaration. So copy the control, my mouse, Control C, and you're going to use that here to paste, and then the corresponding address, copy and paste it here. That's good. So I did the pointer declaration, so all the registers are linked to the corresponding address, and it's all pointer and it's all typecast, and all good to go. So the next step in the writing programming will be, you got to write the main program, because you declared that, and you got to include all of the function inside a declare into the main function. So first we need to initialize all the UART registers. So for that you got to use you can use USART init, and then to transmit and set data, you can you got to install that inside. You're calling the function basically, then you got to write the function for the initialization. So make sure the register name, the function name, it's the same, otherwise it will throw an error. So init then that's a function declaration. Now you writing the function, what's inside that function is USART init of open bracket and close bracket. So this is where you're going to tell initialize all the USART initialization. So first step is to enable the clock for GPIOA, because that's the port you're going to use. To enable that, you need to use this register, pointer register, Control C, come here, Control V, and that's the RCC clock. So if you remember, if you go back to the port modder in your reference manual, I'll write as GPIO so I can show you GPIO output modder, GPIO output register, output type. So for the port mode, you got to mention which port, because as you know, the 32, it's a 32-bit, and you got to write this modder 2 as USART2 transmit. So you got to use PA0, PA1, that's PA2, and you got to use bit 5 and bit 4 to say which port you are using. So that's the next step. So to do that, you need to enable the clock first and then set the port mode. Sorry, you got to enable the clock first by going there. Enable is just R-ing with yes, R, and yes, enabling that port. Let's enable. So save that. I'll show you step-by-step instructions. So this one lives inside the HB1 ENR. As you can see, now the bit is 00. You got to enable that. So to do that, I saved it. I'm going to terminate and relaunch just to see that enable program work. It's doing the debug, and once it changes, it will. I'll go into step into instruction and I'll show you how that bit will be enabled. Proceed with launch. Yes, proceed. Okay, it's all going to show all this error because U in 32 from incompatible mode USART CR1 initialization of int, because we haven't written for the whole program. It's throwing assembly error. Okay, unknown type name PAB HB1 ENR. It shouldn't throw error. I don't know why it's giving. Going to step. Okay, might have done. What did I do wrong? Include standard input. Int main. You're using int. You're using the declaration. That is all looking good. It should come as okay. Enable. Okay, maybe let's declare all of that being an unsigned value. Say build first to get all the error. 9 errors. give me one sec, guys. I'm just trying to see why it shouldn't show any error at this stage, but it's showing some error. I'm just checking with my written notes, which I have written earlier. And terminate and relaunch, then you go for the second step, int 9. So you written that, you copied all of that int, all of that type controls. php1 then you're r'ing that with enabling that. So I'll try again. Change to debug mode. Let's see, debug mode, building project. Mine errors. Sorry guys, did you pick that up? I'm really sorry, it's my bad. That's why it doesn't. So the ID is really cool. So if you see any red line underneath, that means you have made a typo error, meaning when you typed, you might have hit a wrong key and that changed. And this is one good example, because what I did was copy and made it as 8 different copy and paste, and look what happened. So this is not a good practice of writing code, but I want to explain that in a fast fashion. So I did that, but I know what I did wrong. So see, the pointer declaration, so this doesn't know, the compiler doesn't know what type it is, because I made a simple typing error. Instead of uint, undefined int, and I typed as unit. Because I copied 8 times, it's throwing that 8 warnings followed by link error. So sorry, so I got to go and fix it, which I'll show. It's uint and uint, not unit, uint. Even the color change will get you the clues, but to be honest, I didn't check the exactly before compiling. We are all learning, so that's my excuse. uint 32, uint 32. Uint under 32 underscore t, so that will reflect on this. So what else it's showing? Unknown type name. Yes, did you mean yes, that one? Okay. So now if I go to the correct project and build, this should build now, because I rectified the error. A simple mistake, but yeah, please, when you type, please make sure that you type that particular line, and then make sure it takes with a lot of practice, but it's good that it's happening when I'm teaching. So I'm here to rectify that fault, and I can show you, like, if you face these sort of problems, then you know what to do and what to do for. So this is also a good debugging skill that I'm developing for you as well. So this is what you will face in the real-time analysis. So if you're writing a code, and you will see all this error happen, so don't panic, come to my videos and there is a solution. So you go there and check for yourself, and you can fix it. Okay, so that's happy. So I'm going to set to debug mode, and I know we set the declaration early, but I'm just double checking to make sure it's targeted to the link. Okay, apply and debug. This will change from, this is to show you to enable the clock for the RCC module. It's changing from CC perspective to debug. Once it's done, I'll show you step into execution, and I'll show you how the bit is enabled, how the clock is enabled. Okay, it's asking to switch. Yes, switch. we're dealing with STM32, so we don't need to worry for now. Cortex M4, so that's downloaded. So now if I go and keep this open, and you please watch this AHB1 ENR, just this value. When I go to step into, it goes directly there, and see, now the clock is enabled. Before it was 0 cross 0, now it's enabled. So you're doing the right thing by checking whenever. As a learner now you can check, because when you write about 200 lines of code or 500,000 lines of code, then the debugging will be really hard, because you need to go each and every line. Well, the breakpoints will come in handy and the watch points will come in handy, but still you need to consume a lot of time to fix it. So as a matter of rule, the learning coding stage, when you try to change the bits, try to match that with the register. Go into the register and see, by going into step into run, instead of full run, full resume, go into step into, and if you click that, then you will see for yourself whether you made that bit to 0 or 1. So we asked the bit to 1, so that's what it's showing, enabling the clock. Okay, now the second step is, what is it? It is enabling the peripheral bus clock. Enable the clock for USART2, because that's connected to the peripheral bus, which is this pointer register that we declared earlier. So we're going to set that as to, again, simple R. You need to enable this undefined 1U, and you need to shift 17 times. I'll tell you why 17 times. Just one sec. So save for now. So you're trying to enable this. So go back to the register. So this is, as you know, you are setting to USART 2 and you're using port A pin 2. So this is port A pin 2. You already set the GPIO motor. So now you asking the APBI in the RCC. So we are in a GPIO. So I'll go to the easy way. Also you can click that, and then you can go directly to RCC files if you can see RCC in here. If not, then yeah, reset and clock control. So if you go there and expand RCC registers, so this is where RCC register starts from 99. So why load, still downloading. Okay, further down, so we need RCC APB1. So RCC APB1, that's a peripheral reset. Oh, sorry, that's a, yeah, that's a peripheral reset. So that's on by after it downloads. Okay, so this is the register. We don't need the reset register. We need AHB1 ENR RCC underscore RCC underscore APB1R, which is, go back, click the index. This is inside the reference manual, the STM32 reference manual. You have to go to RCC register, and we are after RCC APB1, RCC APB1 ENR. So that's the HB1 ENR. We need APB1 ENR at 6311. This is the register we are after, RCC APB1 ENR. And as you know, by this register, the USART2 we're going to interface with, it's on pin 17, so bit 17. So that's why you need to do 17 shifts to the left to get to there to enable this pin. So that's how you have to write the program. So that's this step. So I'll just terminate and relaunch, and I'll show you the bit value change here. Okay, still doing conversion from CC++ perspective to debug perspective, so I got to wait. We got to wait until it changes, and I'll show you the bit change. Yeah, switch. So as we already enabled the clock for the GPIO port A, that's enabled. So now I'm going to go into showing both, enabling the advanced high performance bus clock and the advanced peripheral bus 1 clock. So those two has to be enabled first, because we are learning USART, and USART works with clock signal. So the data transfer syncs with the clock. So that's why you need to do these two steps first. Okay, we are in debug mode. I'm going to click step into, and it will come to first stop at port A clock enable. Going further, step 1, see that bit as enabled. So the next one will be this port bus. Step into, watch APB1. It got the address location, the value, and now it's going to change. Step into, why you are not changing? Come on, change APB1 ENR. Zero cross 2000, so 30, 3840, 3840. Need to stop and relaunch. Maybe hasn't gone through the second step. Just one sec, I got to show you base address. Okay, still waiting to be debugged. And also when you do the debug, you can also see the was about to capture the LED status, but yeah, okay, never mind. So now AHB1, so going to step into APB1 ENR, AHB1 ENR, and this should change AHB1 ENR, it updated 01. So the next one should go as well to APB1 ENR, 0th bit, so you what did I do wrong? I think I did the port declaration as 17. Yeah, 1U17 should be 1. Terminate and relaunch, step into USART in it, PAB1ENR. It's getting the value of it, but it's not showing the allocation. So one sec. Oh, sorry. My bad. Sorry, okay, APB1 ENR, it got the general value, but we are only toggling the bit on 17th bit, so which is this bit. See, that's enabled. USART enabled. So we are going to enable the clock on the USART 2, so this is the bit. I was looking at this address, sorry, my bad. Okay, likewise, you can also see which bit has enabled. So AHB1 ENR, so GPIO enable, so that's 2, that's the one, GPIO enable 01 port 2 0 cross 1. So now the clock is finished. I'm sure you all waiting to get a bit of a break, so I'll give you a short break, so please go and enjoy that break, and when you come back I will show you further along. So Hello, welcome back. I hope you enjoyed that short break because when it comes to programming in the real industry, when you start anything from scratch, initially you need to get the thought process going on your head, on your mind. So, therefore, if you get into the industry, all the coders sometimes, well, everyone code differently. I take a lot of breaks when I do from scratch. So, when I go out for a short walk, I get the idea, come back and do it immediately. So, it's a good practice to get a bit of a break. You don't have to sit in front of your computer and start to code until you finish. So feel free to get out and come back so you can be more productive. Yeah. Okay. So we learned the clock enabling. So now the third step is you got to set the port motor. Port A. So set the GPIOA. Set GPIOA port motor. To do that, you got to copy this, and this is where you are setting this to say going to use as analog function. Sorry, alternate function. What am I talking? Alternate function. Okay. Port motor for alternate function. So as I said, the port motor is where you're using that, and you're going to set bit 5 and bit 4 in port A as 10. 10 represents alternate function. So simple R, and you're going to enable pin 5 undefined, enable pin 5, basically setting it to 1, and then you need to use pin 4 as well. So just copy that once more, and please be careful with copying because you may make mistakes. To represent in programming, another tip, you can't write 0 directly. You can't say 0 u as 4, so you need to use, instead of R, you're going to use and then you got to negate. Negate means it toggles, so it takes the other value. So by writing like this, it knows that this bit 4 has to be 0, not 1, and this is another way of writing. So PGIO motor and like that. So you got to write that. If you want, you can check, or I can go further and finish the configure, and then I'll show you. Okay. Why that mode? I'll just put as mode. Okay, I'll show in case if to see this port 2 has been configured, port A pin 2. So terminate and relaunch. This will show, and this will show in the GPIOA port. Bit 5 and bit 4 in port A will change to 10, and I'm going to ask you what 10 is. See if you can get that in the register. It's loading. 89 switch, yes. Okay, we are in, and I'm going to run as step by step so you can see this port change, because we're using this GPIO enable as port motor. So I'm going step in, see that the clock is enabled, GPIO A enable, and then come to APB1, the next step. So now if you see, this bit will change HP1, and we are in GPIO mode. Where will this be GPIO mode? We are in the register RCC. So we got to go to GPIO A, and we're going to change the model type, which is this model 2. I'm going to ask you the question 0 cross 2. What is 0 cross 2? If you put your mouse there, and you will see the binary value and the hex value. So that's in decimal. If you leave there, it will show it changes to 02 is 10 in binary. So in decimal it's 02. So that's what it shows. So now you set the that port mode as an alternate function. So now you need to go and specify what alternate function type it's going to. And this is where the control register and the status register for the USART data register and baud rate, this is all will start from here. So the next step is to configure the USART module. Configure USART module. To do that, you have to start with the alternate function, and you're going to enable those three as you learned from earlier. So we are now doing this bit telling what type we're going to use. So remember, we used 0111 in the alternate function register low. So that has 4 bits. You need to copy 4 times. Control V, yeah. And then you can start with the same way as you see in the register 11, 10, 9, 8, or you can go the other way, 8, 9, 10, 11. It's up to you. It's the good practice is up to you. Either way you can program, but the main part is if you want to negate, you have to negate that bit. If you want to don't negate, just leave it as R. So I'm going by how you see the register. I'll show you how you see the register. So we need what register? APB1 we finished. We need USART2 register. So now alternate function AFRL register we need. Okay, AFRL, it's in GPIO. So if you scroll down, we go into the register, and I'll show you why we're going for AFRL. Okay, it's about to go there, but it's already there. Okay, output register, pull down register, output data register, alternate function. So we are here. So we are writing, we are linking PA2 to USART2 in the alternate function mapping. It's using AF07 alternate function 07, and where the 07 lives, it lives here in 11, 10, 9, 8, 7, being a 32-bit. So if you convert, and if you'll get 0111. So alternate function selection for port for values 0 to 7, you got to go to low, and if it is values 8 to 15, you got to go to the high value. So that's what it means. So to write a 7 in decimal, that's 7, but in binary this is 0111. So that's what you need to write, AF7 as in binary. So this is why we need, I'm going to show the register. I'm going to write it as it is. 11 you need to set as 0, 10 you need to set 1, 9 you need to set 1, 8 you need to set 1. That you will see by this 11 as 0, 10 as 1, 9 as 1, 8 as 1. So this is what I'm writing the alternate function program now for the step. So I'll minimize, go back to IDE. So what did I say? You can't write as 0 directly, so you need to use and you need to negate that. negate, and then tell that bit to be 0. Oh, sorry, 11. Okay, so next is bit 10, and you need to R, just simply R with it, and you got to say 1 U, and that's bit 10. Come on, and likewise, because you're setting as 1, so you can just R and you can just use this. So that's for bit 9, and here Control V, you can set that for bit 8. So now we gone to this step. I will save, terminate and launch to show you this bit in the AFRL change. I'm sorry, I'm going from scratch, so I want to show you and teach you step by step. That's why when I write one register, one address, one line of code, and I'm also proving that in the register, whether you're writing the code and you're actually verifying it in the register to see its output is there or not. So this is a must. So likewise, you will also get the speed as you move further along, but I'm showing you what are all the behind the scenes happen when you write the program after you compile. Okay, we are here, and the AFRL, as you would know, it will be in this register AFRL low. So we are setting bit AFRL 7, bit 11 to 8, so it will show in here AFRL 2. Double check, it will show AFRL 2 0111. Okay, AFRL 2, you will see the changes in here in this register. So I'll just go step into, just show you step by step, and enable, and now peripheral bus. Now it's going to set the motor. Now set the motor. So now it's coming into the alternate function register low. So just pay attention to AFRL 2, see what happens at the end of all this 4 bits. So see, it's already changed to binary value 4. So what is that? Decimal value. So now it has changed to 100, but we haven't finished as it's only a step into. So we need a 7. So now it's 6. Okay, so we did the bit declaration. So as you know, 7 is in decimal, in binary it's 0111, so that's the representation. So this is how we have to write a line of code and then come to the register and check for yourself whether you write it correctly or not. So this shows the whole value. So the AFRL 0 is 0, AFRL is 1, so bit 0, bit 1, AFRL 2, so that's where the 700 comes from, 0 cross 700. Yeah. Okay, so what is the next step? So the 5th step is you need to configure now all the USART registers. So start with status register, configure USART module status register. So this will be, sorry, still we are with GPIO A declaring alternate function type. Function type, and now we are setting the module starting with the status register. So this is where this will all be coming in handy. So you need to copy that, copy, come here and paste. So you got to enable this, you got to set this. So we go in here and USART CR1 to write that. I'm just checking whether I covered everything. Just one sec. Okay, configure BR to 900 status register. USART enable. Okay. We got to write and terminate. So port mode 9, 10, 11. Yeah, written 9, 10, 11, which is good. Then configuring. Okay, the next step, we don't have to register the status register. That will happen inside the function. So we'll directly go to configuring the USART module baud rate register, baud rate. So to do that, you need to go here, copy this baud rate, register, and you're going to do that calculation, and you can write remember the calculation that I listed here. This is a baud rate calculation, so you need to load this 0 cross 0683 directly into the program. So all you got to do is 0 cross 0683, and this will put the value, baud rate value, into this register. Okay, so the next step, I'm just going step by step, so in case if I miss, then I will let you know what I'm up to. Okay, then the next step is we need to enable the control register, because we need to verify the data transmission happened or not. So the sixth step would be configure USART control register. To do that, you got to go and copy in this. Let's see, Control V, and we are basically setting this to we're going to write today, so we're going to transmit, so we have to write the data. So for that, you got to R with this value 0 cross 008, sorry, being a 30-bit register, so that's what you got to write as a 32-bit. This is CR1 to have set the USART UART enable, and then you need to set this one. I'm just checking. Okay, baud rate. And then you're going to use, first we need to tell the data transmission, then you need to copy this and enable the transmit enable, which I will show you shortly. So for that, you need to enable this address. Okay, just save. So we need to go to USART2 to show you the transmit enable. We are in reference manual. I'll go to USART register by going to contents. Come on, contents, show us. Yes. You're going to go to USART2. So it's DMA, GPIO, RTC, I2C, USART2. Yeah. Then you need to go to USART registers. So you're here, USART register, and you're using control register 1. So that's the USART register, control register 1. You need to enable this bit, transmit enable, to start the data. So that's why you set this bit as 1 and then all the 3 bits as 0. So that's why you need to write this. So what is 1000 in binary? Sorry, that is in binary, but what is it in a 32-bit? If you convert that to decimal, that will come as 8. So that's why you're setting the first bit of the 32-bit first as 8 to enable just this bit. I'll see if I can explain with the point. I'm just trying to explain how that 0008 happens. So I'm just opening a Paint. I'm just drawing. Just give me some sec. I'm just drawing a register. So imagine that's a 32-bit register. So it'll take a long time. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not a good example, but I will show how the representation is. So I need to write 1 there, 000. I can't write. Sorry, pencil. So I need to write 1 here and 000 here. That's a 0. That's a 0. And this is a 0. This is bit 0 of the 32 bits. That's the first bit. And this is the second bit. And this is the third bit. So you know 32 bits, 32 bits, 32 bits will be like this in the register mode. It will be first 0, it will represent bit 29, 30, sorry, 28, 29, 30, 31 because it's 0 to 31. And the next will be that 8, and the following will be that 8. And this is just a bit representation. So the first 0 will represent this 0 to 8, 0 to 7, then 8 to 15, 16 to the rest, so forth. So you have to write 8 here, so that's why I'm writing bit 3 1, so this will become 8. So out of the 32 bits, that's how we have to write. Hope you are clear with that. Okay, and then you setting CR1 as 2 1 cross 2 000. So these are all reserved, so we are not worried about all this. So we need to transmit this as 2 000. So this is all 0 0 0. You need to write a 2 here, which is bit 13, bit 7. That's TXEIE, bit 7, bit 2. So this is what you write as 0008. And then to enable the, this is to enable the USART enable. So what this is, if you go to the USART register, we are in GPIO register. So if you go here and if you go to control register 1, and we need to enable this bit 3:1. So I'll go save and I can terminate and relaunch just to show this so far what we have written. We are not far off, so we are nearly there, and you can see and verify your USART communication in Arduino. You got to download Arduino. I deleted. I will show you the download of Arduino IDE as well. Okay, it's still debugging, debugging. Yeah, still converting from C perspective to debug mode. I want to just show you that USART enable. Yeah, switch, and we are in USART 2 CR1. We need the T1, this bit. So I'll go step into. Once it comes there, then you will see. Until then you won't. So it's gone to peripheral mode enable clock. Now it's setting the GPIO motor 10, letting to say its alternate function has been enabled. Now he's choosing the alternate function register, AFRL, and step into. Now it's going into this step. It will execute that. Now the baud rate register will have this value. So if we go here after this, the baud rate, step into, see, you have written that baud rate value directly into that Mantissa. You might have known and you studied all of this Mantissa and fraction, so that's why we calculate this 683. Okay, we're worrying about this control register 1. So I'm going to hit another step into. See, it changed. So we just enabled the USART, and the value of that USART, to enable that, if you put your mouse there, and that's decimal 8, so that's what we written, 00008. And then another step into, and 2008 for. So you need to enable this USART enable. So see, this is enable, and this also enable. So that's the meaning when you write control register. So you writing two different of the 32 bits. You have to enable first the transmitter enable, and also to send the data, and you also have to enable the USART. So these two bits have to be represented in decimal value to binary value. So that's what it's shown there. So that's to enable transmitter enable, or set, I should say, set. And this is set for USART enable of the 32 bits. I'll just write here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So if you convert this, then you will see this value. So that's what happened there. And for here, you're going to enable that. So to enable 2, you got to enable, I'm trying to do the math in my mind, just give me a sec, to represent that into 32-bit, so you will understand. So 13 of 1 UE binary is 1000 followed by all zeros and 10. Okay, 10 is 0, 1 2 3 4. UART enable UE. Let's go to the register. I know I'm a little bit confusing you, so I'm just going to the register. You need to enable, that's a baud rate control register. You got to enable this 13th bit as enable as well. So to do that, we have written 1000, so that's 8. 1 2 3 4 5 6 7 8 9 10. So the 10th pin, you need to enable that as 1. So what do you get? Because it's all represented with 4 bytes, so that's 8 0 to here, 0 0 0 0 up to here, then it's 0 1. So what is 1 0? It's 2. So that's what it is. That's what it is, 0 1. So because that's the 10th bit and the rest are all sorry, that's the 13th bit is 0 12 11 10 9 8 7 6 5. Fourth bit is 1 there. So in order to use this in that register, I will go, yeah, because it's all reserved. That's okay. It's all reserved, so all will be 0. Only the 4th bit, only the 3rd bit will be 1. The rest are all 0 for enabling this. For enabling UE1, this bit will be 0 and anything before this will all be 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros will be there in the front. Okay. So now we enable both. Okay, now we need to do a write function so that we can communicate and do the data transfer. Okay, now we're writing the write function, so we need to declare the function first. Function declaration void, we are writing for USART underscore write of void. Okay, you got to call this, but we are not using this function, but you got to call it here, right? It's there, and you're going to write that function void USART underscore. This is for writing and checking the value using a printf statement. So to write that, you need to send a character. Sorry, it's not void, so you are sending a character actually, so it has to be int character. So you're sending a character in the argument, and if you recall in the system call, if you want to say, I'm going to give this example day 2. If you recall in system call, we used a printf statement. To do that, you copied this to see in the console window, so you need that, but we are now writing just a direct input to check on the serial terminal. So to do that, you are writing this int write function, and you are just writing directly, you're putting a character, put character. So that's what you are doing it here in this main C. Input put character, put char of, what is it, int character, and then you're returning that character value. Okay, so this is UART right. Okay, sorry, that's not the UART right, that's for the printf, which I will show, but before that we are writing the UART write function. So the UART write will have to satisfy and check the data transmission. This is where we need the status register and the data register to get in to do its job. So to do that, int USART int character. We're going to use this in other part of the program, so I will still keep it. So USART write is, I'm going to just write a simple while not equal to checking with first the status register to see whether the data is ready to be received. Status register, and then you need to AND with this value to get your first data. Okay, this is basically saying we have to write the data and save it in the buffer and wait for it until it gets empty, and then you get the data out and show that in the you are enabling the TXE, the data transmit enable by going here. What that means is USART, you are in status register, you got to enable this register TXIE, ideally CTS TXE. So this bit you got to enable bit 7. Bit 7 is transmit data register empty. So you need to say that the data is ready to be transmitted, so you need to enable that. So this bit is set by the hardware itself, so the TDR register acts that, and if you send a 1, that means the data is transferred to the shift register. If you send 0, that means the data is not transferred. So you have to enable that first by writing this, and this 0080 is to enable that bit 7 TXE enable. So that's what, if you calculate, that will come as that. And now you got to wait until the buffer gets empty, and then you're going to read the data back. So to do that, you got to, where are you going to load? You're going to load the data register. So this is where you're seeing the data. Control C, and your value will be, you're setting this as the enable, so character ending with high value, 0 cross FF. So this is to wait until the buffer gets empty, and then you're retrieving the data, the character as 1, and loading that into your data register. So this is just a simple write instruction, and this is how it works in. So just save, and I'm going to write the printf statement now. So just to print and see, I can just declare a straight function as input character like that, and I'm going to call whatever you're going to write, the USART underscore write of what you're writing, the character, and then you return that character. So this is a simple function. And this is to see the output in the peripheral, so you need to include, and to see it in the function, so you need to go into your main function to see the printf statement. So you got to write it here, you have to check this in the output. So I'm just writing while of 1, I'm printing the statement, so printf hello world from A to Digi learners say learners, yeah, and /r /n, and I'm ending this. Okay, so all the program now done. I'm just looking at other things to see if I missed anything. So now we can see the output in the serial terminal, which is what we want. I'm just checking if I missed anything. UART right, and then int main. Can be USART right. It doesn't matter where you put the function. It can be before or it can be at the end, but just to make more uniform, I will keep this before the main program. So Control X, I'll keep it here. Right function here written, that's the main. Okay, learners, yeah, I'm happy with that. Save, going to build the project, minimize this. And doing a right click, okay, terminate and relaunch, because it's already in the debug mode. So while that is doing, I'm going to go here and download Arduino IDE so we can check the output. So just go into Google, we're going to download Arduino IDE, download. If you click that, so click the Arduino download and install. This will take a while. I can give you a short break, so once this is done, then we can check the output. So please go and enjoy that break. I'll see you back shortly. So do this on the installation as well. Go to Google and type in download and install Arduino IDE, and then go in and click on the download. There will be a download option. Still it's loading. If you don't need Chromebook. And download Mac Windows, yeah, download the latest release. Click on the download the latest release, that will turn down. So this will take a while, so that's why. Okay, it's going fast. Okay, I'll show you this as well. It's not far off, you'll see the result. I'm just as keen as you are to see the result. We did all the hard work, we learned how to write, and now it's the time to see the reward of your program, to see that output. So we're going to see that output shortly, so just bear with me. Not long to go. Okay, then double click on the Arduino IDE, the downloaded files. It will check for spam or anything like that. So it's checking my antivirus thing and it's saying it's okay, so it's going to open soon. Just give me a sec. It's opening Arduino IDE. I'll just minimize this. Also switch that to perspective mode. I downloaded, I don't know where. It's still loading, sorry. Okay, it's loading on the background, which I will show now. So that's the program. So we went and downloaded Arduino IDE by going to Google and typing Arduino IDE. This is what you get. And we are setting up Arduino IDE. I agree. It's only for me, so click next. And then by default it goes and sits in programs under Arduino IDE. Just click install. This will install the IDE. This will take a while. I think it has to check all the background check and all the necessary files, and when it's downloaded, it will download the option in the desktop. You got to double click that, like the STM32 Cube IDE. This is also another IDE. You need to double click this, and this is where you can see the serial terminal, serial communication. So from one ID to the other ID, you're going to see it. In the meantime, I'll see why this red error is red yellow line. Hello world. Okay, because it's in a string. Okay, it's showing warning. Okay, nothing to worry. Nothing to worry. All good. Character, yeah. Good. So still loading, I guess. Yeah, nearly there. Nearly there. Sorry to keep you waiting. Or how about this? I'll wait for this download. I'll give you a short break. I'll see in a couple of minutes. Go and enjoy that break, and we'll see the output soon in Arduino. Catch you later shortly. Hello and welcome back. As you can see now, I opened the Arduino IDE and I ran, and you can verify the output here. Hello world from A to G learners. So that moment has arrived, so I'll show you how. I'll just terminate and relaunch the program. I will also open my target board so I can see, and I'm clicking yes. Okay, debug session, it's asking debug session. So I'll open the debug as STM32 application, minimizing this, going to Arduino IDE. Zero errors, zero warnings. As you can see, the program is running with this red light. It is loaded to the microcontroller, and on the background it's still doing 89%. On the background I opened Arduino IDE. I click on switch, and I click on run here. I'm waiting for the IDE to open. Okay, you got to debug, run debug as debug STM32 application. Yeah, okay, switch. I'm opening the IDE. Then, as you know, this target board is connected via COM3 to the computer, so you need to set that in the Arduino IDE, and then you have to hit the reset button, and that will start to communicate. Okay, so it's loaded. And it's still checking on the debug mode to change to debug mode. While it's doing that, you're going to go and select the board. So you know this board is connected to COM3. Select the board port and select Adafruit Circuit Playground. Set OK. And then you go here, Tools, Serial Monitor, and there you go, output. So now we are able to communicate I2C. Now we are able to communicate USART2, and whatever you print here, it communicates the data transfer, and it comes out as hello world from A to G learner. So that's what we typed here. This is what we typed. As you can see, this is what we typed. Hello world from A to DG learners. Hello world from A to DG learners. So there you go. The program is working and well done. I'll go and do a recap of the program. So this is inside hash include standard in .h. First you got to copy all the registers with memory addresses, and then you have to declare as pointers with the addresses. All the clock, the PA HB1 enable the RCC GPIO port A clock. This is the advanced peripheral bus 1 for USART2 peripheral clock. This is the port motor, and this is the alternate function register low, and then you need to set all the USART registers. You got to configure the status register, the data register, baud rate register, and control register. And then you got to initialize the USART first by writing enable clock for GPIO, enable the clock for USART, then setting the port mode as 10 for alternate mode, then declaring that AFR low register, and then sending the baud rate, setting the baud rate with 9600, and then you got to enable the transmitter and enable and USART enable to configure. And then we are writing to USART while USART to status register when the transmit data empty is ready until it gets 0. Then once it gets 0, then fetch the data and display from the data register. And to use printf statement, you got to use another function, int IO, put character of in character, and whatever you type in the printf, it will start to run the UART right, and this will print, and you can view the output in any serial terminal. I open Arduino IDE. I also showed you how to install Arduino IDE, and this is how you check and verify the output. So voila, you learned the first communication protocol, USART transmit. The next session you're going to learn about USART receive. So going back, just give me a sec, I lost my mouse. I'll minimize this so it's done. So we hit the baud rate calculation, This is the USART write program. We write with USART status register. You have to enable this TXE, transmit data register empty. TXE, this transmitter data register empty, and once it's empty, then send data. Data is transferred to the shift register by giving 0 cross FF, means 0 cross 1. And then in the USART data register contains a received or transmitted data character. Depending on whether it is read from or written to, the data register performs a double function since it's composed of 2 registers, one for transmission and one for reception. The transmission register provides a parallel interface between the internal bus and the output shift register. Internal bus and the output shift register through the APB1 AHB. Through this communicates to this via the bus. When transmitting the parity enabled bit set to 1, USART CR1 register, the value written in the MSB bit 7 or bit 8 depending on the data length has no effect because it is replaced by the parity. So that's what we learned. So what we learned today so far, we learned about what is an UART, and we learned about the differences between UART and USART, and the general steps when you want to communicate, when you want to do the data transmit. There are a few steps that you got to learn. So we copied by the memory address, then enable the clock, and then we set the port mode register to alternate function and chose alternate function register low, and then we went into configuring the USART2 module registers, and then I showed you line by line from scratch. You got the UART demo. As I said earlier, you got to develop your mindset as well when you develop your skill set, and that's go hand in hand. And today's points I would like to bring out to you is managing money is more important than making money. Yes, because you got to know first how you can control your money flow. Otherwise, whatever you make money, you can't keep it or save it. There is 2 different mindset. The second point, one is scarcity and abundance. Scarcity is something you are hesitant to use the money to do something. You're always in fear of what happens. But be in abundance money mindset. The more you invest on, the more profit or more positivity it creates. So be in the abundance mode. And also be using in the arigato technique, that is an abundance technique. And I would recommend you to read these 5 books about money making and managing money. Thou shall prosper, happy money, Rich Dad, Poor Dad, Atomic Habits, Think and Grow Rich by Napoleon Hill. This will all give you that managing money. It's really good, worth read it. Also, don't forget with your involvement, write down your top 10 goals, and you write 10 ideas to achieve that goal, and at least spend 30 minutes to do some sort of exercise or go for a walk, and at least dedicate 15 minutes to do meditation, and 10 minutes to visualize to actually achieving those goals, and then 10 minutes to focus on your daily plan activities for the rest of the day or for tomorrow or for what's in the next week. Then 2 hours of learning will get you 2 points. Please post all your achievements in the Facebook group so everyone follows each other, and we're all trying to help each other and learn from each other, and this will motivate us. Excuse me. There is combo internship coming up your way. I don't want to cram everything into one module, so I divided into 3 separate modules. So you already learned beginner and you are in the middle of intermediate. Please also do purchase our advanced course so you can get the whole Cortex M series information and all the knowledge and all the projects that come with it. It's really good for you. And also please stay tuned with our more internship bundle combo. You get all of the courses coming your way, and you will be the first person to know and to upskill yourself and to learn a bit more about everything, and these are all coming your way, so please stay tuned. And I take this opportunity to thank you so much for all your patience and going through with me and learning with me line by line to transmit data in using USART2 with TX. In the next session, you're going to learn about the USART receive. So go and enjoy that lovely break that you deserved from the screen, and take care. This is Arul. I'm signing off on behalf of A2DG. Hooroo for now. I'll catch you in the next session. Until then, take care. Bye for now. Catch you later.